Hello everyone. In last session we did a series combination. Today we are discussing about the parallel combination. When the three resistors R1, R2 and R3 are connected in parallel, then what is the resultant resistance is there that we have to calculate. So here we have one junction A and another junction B, where from the junction A, three wires are coming out, and from that wire current I1, I2 and I3 is flowing respectively. So that current is flowing through R1, R2 and R3 respectively, and they are again joining together at the potential B or at the junction B. So this total combined current is I is flowing through this circuit. So here whenever we are taking parallel combination, the current is divided into the given branches. But in case of series combination, current will remain same and voltage is what we are getting different voltages across the each component. But here, as is a parallel combination, across all these three components or all these three resistors, the voltage drop is remains same. Voltage will not be divided, but current is gets divided up to into certain branches. Okay, so we must know that Ohm's law, V is equal to IR. Again, with the help of this Ohm's law, we are deriving the final resultant for the parallel combination. So we have to derive an expression for net resistance in the circuit. So here the current is get divided, and here we will get total current I is equal to I1 plus I2 plus I3. So whenever we combine all these three currents and that summation gives what? A total current. Here I took three branches. People can take two branches, people can take four branches, or they can take n number of branches, and according to that this current I is nothing but I1 plus I2 or I1 plus I2 plus I3 and plus I4 and so on like that. Okay, so here for study purpose, for demonstration purpose, we took here only three resistors and which are connected in parallel. So here if we know that I is nothing but I1 plus I2 plus I3, and with the help of Ohm's law we can rearrange the terms and obtain the expression for I. So I is nothing but V by R you can transpose to this side, then you will get I is equal to V by R. So if I want the current for if I want a current through resistor R1, so I1 is nothing but V by R1. V will remain same because V across all the three resistors will remain same. Resistance value and current value is what keep on changing. So similarly we can write I2 is nothing but V by R2, and I3 we can write it as V by R3. Okay, so now we have to combine all these currents. So I will write total current I is equal to here I1 plus I2 plus I3. So we can substitute here I is nothing but V by R. Okay, and then here I1 is nothing but V by R1, here V by R2, and I3 is nothing but V by R3. As I told you, voltage will remain same across all the three resistors. Okay, now here what we can do, V by R, and from this side we can take V common, so we will get 1 upon R1 plus 1 upon R2 plus 1 upon R3. So here V and V are same, so you can cancel it out and you will get 1 by R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this resistance is nothing but what? Total resistance which is present in the parallel combination. Okay, so if you have any doubts in series, or you want to check the derivation for series, you can go for the previous video. There you will get the series combination also. Hope you clear the concepts. Thank you.